What's up, fellas? I'm testing a sodium hydroxide aluminum battery. I basically have a sodium hydroxide solution inside of this U-tube with a aluminum rod and a carbon rod in place. I'm getting 0.42 volts, which may be some kind of misreading. That may not even be an actual reading, I don't know yet. But I wanted to see if this reaction would give me some kind of voltage. So what I'm going to do is disconnect the voltmeter, and it was in fact giving me about half a volt. It's not enough current to run this little motor, but it is generating some voltage there. So what I'm going to do is let this warm up a little bit. Unfortunately, this is a runaway reaction. So if I were to build a emergency battery that uses this, there may be a problem. As you can see right now, I'm suffering from something called polarization. Those bubbles are covering up the active surface area available for generating electricity. Sometimes when you try to start a car and it doesn't want to start and you keep turning it over and over again, this happens to the plates inside the battery, so the current available drops off. So sometimes if you wait 10 or 15 minutes after you've been really going at it, these bubbles will dissipate and it will appear as if the battery has charged itself a little bit, but it actually hasn't. It's just that these bubbles you see here that are collecting to this anode are passivating the plate, if you will, or polarizing it. That's what they call it, is polarization. So even though it doesn't change the polarity or nothing like that. So I just thought it'd be interesting to see if I could get this little motor to run. I'm going to find a smaller motor, let this reaction run for a while, and it'll just be kind of cool to check out. It's still at about 0.2 volts. I don't know if I can get that in there or not without knocking everything over here. Just barely. So that's 0.231 volts. We'll find a smaller motor. This thing ain't gonna work. Okay, with the motor disconnected, there's definitely a voltage spike there. Almost seems as if the reaction went a little crazy too. I'm probably going to have to pull that anode out of there. Wow, I'm up to almost 1 volt. Wonder if a light bulb will work. Okay, I'm hooking up a small light bulb. And that dropped the voltage. Actually, this is not a small light bulb at all. This is actually huge. Drop that voltage back down. I'm going to unhook it and I'm going to see if it increases that reaction. Hard to say. The voltage is going back up. Okay, I have a very tiny electric motor here that I'm going to attempt to hook up. Let's see here. These wires are just too stiff. If I get any type of action out of this, I may build a better version. I just wanted to see for myself what might be possible. Okay, this little motor is doing nothing. So maybe if I connect a few of these in series, I would get some action. Doesn't even feel like it wants to turn. Wow, that voltage really goes down. It's down to 0.01 with this little motor hooked up. So it appears I would just need a couple of these in series. So I may have to array several test tubes in line and make a little battery. I didn't expect to get more than a volt, but I thought maybe I could at least get this thing to power something, but it just doesn't appear to have any current whatsoever. It won't even power this tiny little motor. So I'm not looking into building a battery out of this, basically. The reaction is starting to get a little warm there. At 0.9 volts there, 0.965. Now, I'm going to find a different motor. Maybe we just have something going on with the motor. I'm just going to try this one more time. Once it really gets roaring, I'm going to try it again too, because you really don't want to give up so easy on stuff when you're experimenting. Because sometimes some of the stuff that works the best are things that are nearly impossible to get to work. Just imagine the guy that made the first lawnmower engine or the internal combustion engine and was dialing in the jets. How many people would have given up before they got those jets dialed in right? This camera view kind of sucks here. I do believe this type of battery is used in the railroad industry. They have this some kind of emergency high current chemical battery, and the solution is kept in a tank, and when the battery is needed, a small pump would pump the hydroxide solution into the tank and flow the solution directly over the anode. A pump would actively spray a huge plate anode. It's a pretty cool looking battery, and apparently it has a pretty good energy density. I'm going to look up the energy density and try and post it on the video here of what aluminum hydroxide batteries have. That's me shorting it out. That brings the voltage down to like nothing. So I guess it's not going to get the 1.25 volts. I think 1.25 is like the standard voltage of a lot of chemical reactions. I wonder if some type of ion buildup might be taking place, or anion on one side. Okay, I'm going to go ahead and stop this here for a minute and try and find a little bit better of a motor. I'll go ahead and start the clock so you know how long it's been running since I've edited the video. But so far I'm just getting 1 volt. I may go ahead and decide to build a little series cell. It'd be interesting to know how long this reaction will go before it goes nuclear on me. It will eventually start to foam up pretty bad. Inside this test tube, something called nascent hydrogen is being produced. Nascent hydrogen is a single hydrogen atom that can have devastating effects on metals. So if you were ever thinking of building something that used hydrogen gas pressurized from a reaction like this, you have to consider the metal fatigue properties of nascent hydrogen, especially metal that's under stress from pressure, because metal that's under stress is somewhat stretched out a little bit, which increases the space in between the structure lattice where these little nascent hydrogen molecules can nook in and cause catastrophic failure. But anyway, I'm going to shut this off a second before I run out of data and try and find a motor that will actually run, or a diode or something. So far I'm getting nothing. I can't get the diodes on this to light. So anyone who's interested in the amount of current this thing makes, I'm not getting any current at all. I wanted to show one interesting property of this reaction, is that the surface area of the anode has very little to do with the voltage. Very little to do with the voltage. See, we're hovering very consistently there. Well, it moved up a little bit. It made a liar out of me. We're at 5.2. Seemed like I was getting more of an effect out of this side. That's what I was getting at. I need to rearrange these. They're cross-cornered. Okay. So, this thing is killing me here. I don't know what's going on now. Uh-oh, I'm at a volt. Pulling that thing out of there brought me up to a volt. That's pretty cool. Try this motor again. I'm going to disconnect the voltmeter and attempt to run the motor and see if maybe that'll work. Nothing. Not even the slightest amount of current. For the purpose of comparison, I'm going to hook that little motor up to a dead battery and see what that'll do. Okay, just to show you a little comparison here, I have the motor and I'm going to hook it up to this little battery. Pretty sure this battery's dead. And it runs that motor like crazy. So this sodium hydroxide battery sucks. It's not doing nothing. I wonder what the voltage of this battery is. Let's test the voltage of the battery. It should be 1.25 or 1.5. 1.58. Maybe that ain't a dead battery. Wow. Didn't feel like it. So there you go. If this reaction would have ran this little battery off just one cell, I probably would have taken this further, but I don't think I want to. I need to find a little light bulb and see if I can get it to light. This reaction will probably run for a long time. Man, I just blocked out the voltage there. So that's kind of depressing. No current. Well, I think I'm going to stop it again, and I'll go ahead and log the point at which it just goes thermonuclear on you. Because like I said, this is a runaway reaction, so if I were to make a battery with it, a lot of mitigation would be required to handle this. You'd have to have a cooling system, temperature control, all that kind of stuff. Because you do want the reaction kind of hot. It really sucks we're not getting any good voltage though. Or no good current even. Not even the slightest amount. You know, and I wonder if that has anything to do with my carbon anode. I'm going to do a quick experiment here. I'm going to get a piece of, I wonder what would happen if I just got another piece of aluminum and used it. The voltage is starting to drop because I think the solution has penetrated my electrode. See it bubbling out the top there? Yeah, let's do a quick experiment and swap out this cathode. This is a piece of carbon. It's probably acting like a huge current resistor. I'm going to try a copper wire to start. See how it handles this solution. I'm going to go ahead and remove that. Let that stay idle for just a second. Okay, so I'm going to try 2 aluminum electrodes. The copper did nothing. Kind of a disappointment. And I'm getting no voltage with that. It's not like in the dual aluminum. So I'm going to put the copper back in. Yeah, it's like 0.1. That's horrible. I think I just need more surface area to get the current I'm looking for. That's 1.1 volts. Still not turning the motor. And this is a tiny motor. I'm going to try and find a diode. Ooh, what's happening? Well, that's kind of lame. At this point, I'm just kind of looking at how long the reaction will last. Well, we're about 19 minutes into since the first time I've cut, and it's bubbling up pretty good. Still at about 1 volt, and absolutely no current whatsoever. That's really disappointing. But if I could make a cell that had a decent enough surface area, maybe it would produce enough current. But here's the problem: the size of this thing and the fact that it won't even power this little motor. I would say this battery idea might be worthless, but then again, you never know. I might be doing something wrong here. Maybe just a couple of these things in series would put off quite a bit of current. The reaction's really starting to go. I'm just testing to see if shorten it out does anything to the reaction, like decreases it or increases it. I'm not seeing like any anion flow or nothing. So for the most part, this is a total failure as a battery. Kind of disappointing. I was hoping to make one of those railroad batteries I read about. It's getting very hot, and that is really hot right there. Probably going to eventually start boiling water. Okay, I'm going to try a little bit more surface area. One last little electrode test. A little bit more surface area on that plate. One final motor test. And nothing. So, and at about 23 minutes into the reaction here, it is about to overflow out of the test tube onto my aluminum work plate, which will etch it indefinitely. So, because this battery is worthless, I will not be going any further with this process. I do have several other things going on the back burner, but I don't have any money at the moment to finish those, so that's why I'm messing with this, but I'm done. That's the end of it. I really wish I would have measured the diameter of that rod. I don't think it really matters. Doesn't appear to have lost any size at all. And it gave me about 1 volt for about a half hour. If it wasn't for the fact that that's going to start overflowing, maybe that's really hot. Let me see how hot that is. Have a temperature down here. Some pretty hot stuff. Not sure what's going on there. I'd have to look into what that's creating there. It seems like last time I've done this, the byproduct was a white substance. I don't recall getting this black stuff. That's really weird. Voltage might hit 1 volt there, it looks like. Slowing down on me. Okay, what's going on here now? Oh, those are just bubbles that have made their way over. I see. Yeah, what a rip-off. Nothing exciting whatsoever happening. I guess I just need some big plates. So there you have it. The aluminum sodium hydroxide battery. Some Chinese guys made one of these too. I'll have to find that video and post a link. But I'm going to go ahead and end this here because this is basically just a waste of all of our time.